Beginning with question 21, let's solve the equation using the quadratic formula. Hopefully you guys remember that it's x equals, but because this question is in terms of k, we're going to write k equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So in order for us to find out what our a, b, and c values are, we must move the 2k over to the left side, leaving us with 4k squared minus 2k minus 15 equals 0. In doing so, our a value is 4, your b value is in front of your k or x, which is negative 2, and our c value is negative 15. From here, all you need to do is plug in those values into your quadratic formula. So negative times a negative 2 makes a positive 2 on the outside, plus or minus. So negative 2 squared is 4. We have two negatives here by multiplication. 4 times 4 times 15 is 240 all over 8. We're going to further simplify the radical. 4 plus 240 is 244 all over 8. 244 has factors of 4 and 61. So let's just keep that in mind. And if we separate them into each radical, we can see that the square root of 4 is just 2. So we will rewrite it to incorporate that 2. So 2 on the outside. We're going to leave the 61 on the inside, all over 8. The last thing we need to do is divide by a common factor between this 2, this outside 2, and this 8. We can divide by 2. We have 1 plus or minus root 61 over 4, leaving us with 1 plus root 61 over 4, and 1 minus root 61 over 4. Questions 22 and 23, we need to describe the end behavior of the function. Before we do that, let me give you a key to know how an even and odd function should look like. Looking at our question 22, we can see that this is an odd function because the highest exponent is odd, it's 5. With odd functions, if the leading coefficient, I'm going to label it as LC, is positive, the end behavior should look like this. On the left-hand side, it's approaching negative infinity, and on the right-hand side, your f of x is approaching positive infinity. Now, with the opposite, if your leading coefficient was negative, we would just flip the arrows. So now the left-hand side, f of x is approaching positive infinity, and on the right-hand side, f of x is approaching negative infinity. Referring back to our problem, we already established that this was an odd function because the highest exponent is 5, and the leading coefficient is positive. There's a positive 1 in front of that x to the 5th power. So our end behavior should look like this. So how do we write that properly? We would say, as x is approaching negative infinity, our f of x or our y is also approaching negative infinity. And as our x is approaching positive infinity, our f of x or y is approaching positive infinity. Question 23, we have an even function because the highest exponent is 4. So let's look at how even functions should look like. If the leading coefficient is positive, both ends of your graph should be approaching positive infinity. If your leading coefficient is negative, then both ends of your function will be approaching negative infinity. So going back to our problem, we already established that it was even because the exponent is to the 4th power, and our leading coefficient is negative. So we're going to be looking at this portion. How do we write it? We write it like this. As x is approaching negative infinity, our f of x is also approaching negative infinity. As x is approaching positive infinity, f of x is approaching negative infinity. So just memorize those two, how an odd and even function look like, but also if the leading coefficient is positive and negative, and you should be good. For questions 26 through 29, we need to factor completely. So our function u to the fourth power minus 14u squared plus 40. Notice how u to the fourth can be square rooted into u squared. So what I'm going to do is put u squared in the beginning of each parentheses. Very similar to a quadratic, you want to find those two magic numbers that multiply to 40, right? So we can list out all the factors of 40, but we need to make sure it adds up to negative 14. So let's write out the factors first. The factors of 40 could be 1 and 40, 2 and 20, 4 and 10, and 5 and 8. Of these factor pairs, which could potentially add up to negative 14? This third one. But they need to be negative. So negative 4 times negative 10 makes positive 40. And negative 4 plus negative 10 gives us negative 14. So what we're going to do is we're going to put each number in the parentheses. So in the first parentheses, we can put minus 4. And in the second, we can put minus 10. So we can further simplify and say that u squared minus 4 can be factored out into u plus 2 and u minus 2. And then this second parentheses, we cannot further simplify, so we're just going to bring it down. And that is how you fully factor question 26. For question 27, let's try to use group factoring. The way you do this is you group the first two terms and the last two terms, and you want to take out their greatest common factor from each. From the first two terms, we can take out a 3k squared, leaving us inside with 3k minus 2. And from the last two terms, we can take out a positive 7, leaving us with 3k minus 2. From this step, we can see that they have 3k minus 2 in common, so we're going to take that out and put in its own parentheses, and in the second parentheses, we will put the terms that were left outside. 3k squared plus 7. We cannot further factor, so we're going to leave our answer just like this. Question 28 is also a difference of squares because the square root of 9b squared is just 3b, and the square root of 25 is 5. So now we can take each term and put it in the parentheses. We'd say 3b plus 5 and 3b minus 5. And that's all. Question 29, we are dealing with a sum of cubes. So how can we tell that this is a sum of cubes? First, our x is to the power of 3. Second, the leading coefficient can be rewritten as 5 cubed. And lastly, this constant can be rewritten as 6 cubed. Using this formula and our a and b values, we can just plug in and factor. A plus b, so 5x plus 6 times a squared, so 5x squared, minus a times b plus b squared. Let's further simplify. So 5x plus 6 times the squared, we're going to distribute into each term in the parentheses. So 5 squared is 25, x squared is just x squared. 5x times 6 is 30x, so we have negative 30x. And 6 squared is 36, so plus 36. You cannot factor the second part, so we're just going to leave it as is, and this is how you use the sum of cubes to factor out a function. For question 30, we can use the difference of squares to factor and then to solve. So if we square root the first term, we get x squared. If we square root the second term, we get 8. So we can rewrite this function as x squared plus 8 and x squared minus 8 and set that equal to 0. Now we're going to set each parentheses equal to 0. X squared plus 8 equals 0. Subtract 8 from both sides, leaving us with negative 8. Square root, and don't forget the plus or minus. The square root of negative 8 can be rewritten as the square root of negative 1 times the square root of 4 times the square root of 2. The reason I do this is because the square root of negative 1 is just I. The square root of 4 is 2. And we're going to leave that root 2 as is. X is equal to plus or minus 2I root 2. We have one more parentheses to equal to 0, which was the x squared minus 8 equals 0. Adding 8 to both sides gives us x squared equals 8. Take the square root, don't forget the plus or minus. Very similar to the one we just did without the negative. So we end up with x equals plus or minus 2 root 2. 2 root 2 and negative 2 root 2. So you end up with 4 answers, 2 imaginaries and 2 real. For question 31, we are going to use that sum of cubes formula, but we need to figure out what your a and b values are. We do that by cube rooting your first term. So the cube root of x cubed is just x, and the b value is the cube root of 8, which is 2. Okay, let's start plugging in. So we have a, which is x plus b, which is 2, times a squared. X squared is x squared, minus a times b. So x times 2 is 2x, plus b squared. So 2 squared is 4, plus 4 equals 0. Setting the first parentheses equal to 0, we see that x is equal to negative 2, which is our first answer. Now for the second one, we cannot factor, so what we're going to use is plug in the terms a, which is 1, b, which is negative 2, and c, which is 4, into our quadratic formula. Your negative b, so negative 2, plus or minus the square root of b squared, so negative 2 squared, minus 4 times a times c, all over 2a. Negative times a negative 2 makes positive 2, plus or minus. Negative 2 squared is 4, and negative 4 times 1 times 4 is negative 16. So 4 minus 16 is negative 12, and 2 times 1 is 2. Think of negative 12 as the square root of negative 1 times the square root of positive 4 times the square root of 3. The square root of negative 1 is just I. The square root of 4 is 2. And the square root of 3, we can't change it. So further simplifying, we get 2 plus or minus 2i times root 3 all over 2. These 3 2's have a common factor of 2, so we're going to divide each term by 2, leaving us with 1 plus or minus I root 3. So we have 3 answers. Our first one is negative 2, and the last 2 are 1 plus I root 3 and 1 minus I root 3. The last 2 questions on this guide want us to use synthetic division to solve. We will need to use the rational zero theorem to help us though, and this is what you do. To find all the possible rational factors, you want to find p over q. The p value is always your constant. In this case, it's negative 2, and your q value is the leading coefficient of the function, which is 1. We want to write all the factors of p. All the factors of 2 are plus or minus 1 and plus or minus 2, all over your factors of q, which is 1, and factors of 1 are plus or minus 1. If we further simplify, any number divided by 1 is itself, so we end up with plus or minus 1 and plus or minus 2. So these are all the possible rational factors that this function could have, but we got to test them out. If by plugging in these numbers into your function you get 0, that means that that number is a 0 of the function, and I'm going to show you what I mean. So I'm going to choose positive 1. So if I plug in f of 1 into the function, I get 1 cubed minus 3 times 1 minus 2. 1 cubed is just 1. Negative 3 times 1 is negative 3 minus 2. So if we simplify, we end up with negative 4. Does that equal 0? No. So positive 1 is not a 0 of the function. Let's try another number. Let's try negative 1. So if I plug in negative 1 into the function, I get negative 1 cubed minus 3 times negative 1 minus 2. Negative 1 cubed is negative 1. Negative 3 times negative 1 is positive 3 minus 2. And notice here that we do get a 0. So negative 1 is a 0 of the function. Now that we found 1, 0, we're going to use synthetic division to further simplify and find our other factors. Let's set up for synthetic division. We put our 0, which we said was negative 1, and we put the leading coefficients inside. 1. Notice how we're missing an x squared term, so make sure you put that 0. It's very important, otherwise your answer will be wrong. Now let's bring down the first number. We get 1, and we're always going to multiply it to our 0, which is negative 1. Negative 1 times 1 is negative 1. Now let's add down. We get negative 1. Negative 1 times this negative 1 equals positive 1. Let's add down. We get negative 2. Negative 1 times negative 2 is positive 2, and we end up with 0. This 1 represents 1x squared. One less exponent. Minus 1x minus 2. Set that equal to 0 so we can further factor and simplify. This quadratic can be factored into x minus 2 and x plus 1. Setting each parenthesis equal to 0, we get that x equals positive 2 and x equals negative 1. Notice how we have two x values that equal negative 1. You're going to put that in your final answer. So in curly brackets, you're going to say negative 1 with a multiplicity of 2, because we have two negative 1s as our answer. And then you're going to place a 2 right after. Moving on to the last question of this study guide, we're going to use the same process from 33 to answer 34. We want to use the rational zero theorem to find all our possible rational zeros. P over Q. P are the factors of your constant. Factors of negative 1 are plus or minus 1. All over factors of Q, which in this case is 10. And 10 has factors of plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. If we further simplify, we end up with plus or minus 1 divided by 1 is just 1. 1 divided by 2 is plus or minus 1/2, and so forth. So we get plus or minus 1/5 and plus or minus 1/10. We want to plug in these values into our original function and see if it equals 0 before we can use synthetic division to further factor. I'm going to choose positive 1 because it's just the easiest. Plugging in 1 into the function, we get 10 times 1 to the 4th power minus 7 times 1 cubed minus 9 times 1 squared plus 7 times 1 minus 1. And guess what? It does equal 0, which means that 1 is a 0 of this function. So now we can use synthetic division to further simplify, putting 1 on the outside and then putting our leading coefficients inside. We have 10, negative 7, negative 9, 7, and negative 1. Bringing down the 10, then we multiply. 1 times 10 is 10. We add and get 3. 1 times 3 is 3. We add and get negative 6. Negative 6 times 1 is negative 6. We add, we get 1. And 1 times 1 is 1. And we get 0. We did get 0, which is perfect. This 10 represents 10 to the x cubed plus 3x squared minus 6x plus 1. Now we got to factor this part out. Now let's check if negative 1 could possibly be a factor by plugging it into that function. So if we put in Negative 1 into this new function, we get 10 times negative 1 cubed plus 3 times negative 1 squared minus 6 times negative 1 plus 1. We end up with 0 once you simplify, which is perfect. Another factor is negative 1. Using synthetic division, we're going to place 1 on the outside and put the leading coefficients on the inside. We have 10, 3, negative 6, and positive 1. Bringing down the 10. 10 times negative 1 is negative 10. Add down, we get negative 7. Negative 1 times negative 7 is positive 7. Negative 6 plus 7 is 1. Negative 1 times 1 is negative 1, and we end up with 0, which is perfect, again, because it does confirm that negative 1 is one of the zeros. So now this 10 represents 10x squared minus 7x plus 1. Plugging in our values, we get negative b, which is negative 7, plus or minus the square root of b squared, so negative 7 squared, minus 4 times a, which is 10, times c, which is positive 1, all over 2 times a, which is like this. Now we simplify. We get negative, negative, make a positive 7 plus or minus. Negative 7 squared is 49. Negative 4 times 10 times 1 is negative 40. All over 20. 7 plus or minus. 49 minus 40 is 9, and the square root of 9 is 3. All over 20. So if we add first, 7 plus 3 is 10, and 10 divided by 20 is 10 over 20, which is 1/2. So one answer is that x is equal to 1/2. The other answer is if we subtract. 7 minus 3 is 4. We get 4 over 20. Divide top and bottom by 4, and we get 1/5. So x equals positive 1/5. We have 4 answers and can be written like this. 1, negative 1, 1/2, and 1/5. Yay! That concludes part 3. Thank you so much for staying with me, parts 1, 2, and 3. I hope that this study guide has been helpful. Good luck with your finals. If you already finished, I hope that you did well. If you did not, remember that a bad grade does not define you as a person, will not define your future successes. Just do the best that you can, and you can always study with me next semester to perform better. Follow me on TikTok and IG if you haven't done so already. I'll leave a link below, and subscribe to my YouTube channel if you like my content. Thank you so much again, and I'll see you next time.